Welcome back to Rational Expressions. This is part 2. We want to multiply 2y squared divided by 9 times 27 over 8y to the 5th. So to do this, it's the same thing as with fractions. We simply go straight across. But we can also simplify before we go straight across by looking at what's on the top versus on the denominator. So if we look here, 9 and 27, we know that 27 has 9 in it 3 times, and 9 has 9 in it 1 time. So you can reduce that to 3 and 1, respectively. And we have 2 and 8. 2, there is 4 2's in 8. So we can reduce 2 to 1 and this to 4. And then y's, we can actually do it with y's as well. So there's 2 y's here and there's 5 y's here. Well, we can say, hey, there's 2 y's here. So this will be 5 minus 2, which is going to be y to the 3rd power. So then going across, we have 1. This is just also 1. We have 3 on top. We have 1, and then we have 4, y to the 3rd. If we wanted to do it in a manner that may be easier to see, 9 times 27 over 8y to the 5th. If we want to do it all the way, I can show you that. 2 times 27 is 54, y 2. And 9 times 8 is 72, y to the 5th. And then you will simplify this fraction. We know that 9 is both in 54 and 72, so we'll take out 9 over 9. And taking out 9 from 54, you get 6. Should have known that. And taking out 9 from 72, you get 8. So this will cancel, and then we have 6y squared over 8y to the 5th. We can take out 2 and y squared from 6y squared, and we're left with 3. We can take out 2 and y squared. We're just left with 4 and y third. Like that. These two things cancel. We're left with 3 over 4y to the cubed. So that's how you multiply. Moving on to division. So dividing is the same kind of idea as with fractions. You're going to take the first, keep it, and then multiply by the second. So this is the same thing as 3x squared plus 11x minus 4 divided by 24x cubed minus 8x squared times, and we're taking the reciprocal of the second one, 24x to the 4th minus 36x cubed over 9x plus 36. And you can go straight across, but what I would do is I would factor each of these separately. So for the top one, we have 3x squared plus 11x minus 4. That factors to 3x. Factors to 3x. Hold on. Factors to 3x minus 1x plus 4, and the denominator factors to, we can factor out 8x squared, so we're left with 3x minus 1. And the top one we can factor as 12x cubed times 2x minus 3, taking out 12x to the 3rd from the top. And then on the bottom we can take out 9. So we're left with x plus 4. So this is how these each factor. And then we can look at the factors and we can simplify. So it's top on bottom. We see that x plus 4 is here on the top and it's also on the bottom here. So I'm going to slash because they cancel out. 3x minus 1, 3x minus 1 are also on the bottom here, so I can slash. And it looks like very little else cancels. We could factor out a 2 here. We could also factor out a 3 instead. I shall do that. So instead of 9 and 12 have a common factor of 3. There are 2 3's in 9. There are 4 3's in 12. And then I'm just going to multiply across because it's getting too complicated. So 4x cubed times 2x minus 3 on top. 8 times 2 is 16 times x squared. These two things can now cancel a little bit more. We can cancel the 4x cubed and 16x squared. We can take out an x squared from both. Or you can just say, hey, the top minus the bottom. So 4 over 16. Taking out a 4 from 4x cubed, we get just 1, and we get x on the top, 2x minus 3. On the bottom, we're left with 4 after taking out 4. And we don't have any x's left after factoring out x squared. So it's just 4. And this is as simplified as it's going to get. That's a complicated problem. Next step is to simplify the complex fractions. You'll have to do this on your homework. So a complex fraction is when you have fractions within your fraction in this format. So the way you're going to simplify a complex fraction is you're going to multiply by whatever's in the denominator over itself. So here we have k in both denominators of each of the little mini fractions. So we're going to multiply the entire fraction by k over k. So that's the only thing in the denominator, so we're just going to multiply by k over k. This won't change the value of this fraction. It will simply, because k over k is 1, but it will simplify it and make it look better, essentially. But we do have to remember that k cannot be 0, even after we simplify. So doing this, so k times 6 is 6k. And then multiplying k by negative 5 over k, well, because it's on the top and the bottom, they'll cancel out, so we're just left with minus 5, like that. On the bottom, we have 1 times k, which is k. And then 5 over k times k will cancel out, so it's just going to be left with the numerator plus 5. So this is how you, and then this is as simplified as you're going to get it. So that's kind of how you do complex fractions. Here's a slightly more complicated one with lots of little mini fractions, but they have different denominators. You're simply going to multiply the entire thing by whatever's in the denominator, the LCD, so to speak. So we're going to multiply this entire fraction by a plus 1 and also by a, top and bottom. So this won't change the value of this fraction. It will, because this all by itself equals 1, but it will simplify it so it looks prettier. But we will have to remember that a plus 1 cannot equal 0 and a cannot be 0 as well, even after simplifying. Okay, so a divided by a plus 1 times a plus 1 times a. The a plus 1s will cancel. And then we'll have a times a. So this will equal a squared for that first term. For this one, if we multiply 1 over a by a plus 1 times a, the a will cancel because we'll have a over a. But the a plus 1 won't. So a plus 1 times 1 is just itself. So it's plus a plus 1. So that's the numerator. Moving on to the denominator. We have 1 over a times a plus 1 times a. The 1 over a times a will cancel. So we're just going to be left with a plus 1 times 1, which is just a plus 1. Moving on to this one, we have 1 over a plus 1 times a plus 1 times a. Because this will be on the numerator and this is on the denominator, they will cancel, it'll just equal 1. We have 1 times a, so this is plus a. So this is a squared plus a plus 1 over a plus 1 plus a, so 2a plus 1. So that's how you simplify a complex fraction, and that will do it for rational expressions.